Okay, next up, Frank Fernandez is here. He's going to talk to you about innovation. He currently leads a small consulting company with clients in both the defense and civilian research and development sector. He has served on the Defense Science Board. He was the head of the Naval Research Advisory Committee. He's been on the Chief of Naval Operations Executive Panel, and he's been on the Department of Homeland Security S&T Advisory Committee. He was formerly the director of the Defense Advanced Research Projects Agency, commonly known as DARPA. He's been the president and chairman and founder of two companies. The first was AETC Incorporated, and that was a firm specializing in environmental surveillance. And the second was Arete Associates, whose focus was using advanced sensors and signal processing for the detection and classification of concealed targets. He's a graduate of the Stevens Institute of Technology and Caltech. Frank.
How you all doing? Good. Okay, it's about time for me to wake you up a little bit. I was just thinking in the talk by Mike Griffiths, he came on when he talked about that nun on sex education. That sounded like a perfect DARPA program. Yeah, you know, the one that we might really get the director interested in. First, I want to thank you all for asking me to speak here today and to tell you how important I think it is that the Army leadership is doing a very important thing in recognizing the need for innovation in military operations. I'm the oldest guy here by a long shot, so I think what I'm going to tell you first is that the word innovation is very interesting. When I got to DARPA, it was the buzzword. Okay, the late 90s, innovation, we had just had the big boom, you know, with the dot-com companies and everything, and that was the word, innovation. By 2001, when the new administration took over, the word innovation disappeared, okay, and the word transformation replaced it. And it was transformation for about 8 or 9 years, and I guess we're back to innovation now again, which I think are all parts of the very, very similar thing. Just as an aside, I think the last 13 years, the Army has demonstrated and innovated a great deal in the two wars that we've been fighting. These weren't things that were maybe planned for, but I think there's no question in my mind that the Army deserves, okay, a lot of applause for having dealt with a very difficult enemy in a very, very difficult environment. Because of my background, I'll tend to emphasize more the technical aspects of innovation. I think the other talks have already shown that there are many different aspects to innovation: organizational, financial, okay, process, and everything else. But I'm going to talk about innovations that are driven mostly by technical criteria. And I'm going to begin my talk. Where's my little? I'm going to begin my talk by talking about these things. First, I'm going to talk about something that Peter Drucker, who used to be a management consultant, very well known, talked about in the late 90s. And I'm going to talk about the national defense future, what I think it is, and the need for innovation, and some lessons learned about radical innovations while I was at DARPA and while I was working on some other programs. I'm going to talk about some examples that I hope will reinforce some of these lessons that I think we've learned about what innovation is all about. And finally, I'll give you just a few takeaways for the Army that I think you might want to consider. 21st century management. Peter Drucker, back about 15 or 17 years, more than 15 years ago, wrote a paper in Forbes magazine. This was right after Clayton Christensen's thesis, okay, in his book on the innovator's dilemma, which came out, I believe, in '97. And then Peter Drucker came out with his own version of this thing, where he talked about what is happening in the world and why management is going to have to change its paradigms for the 21st century. The amazing thing is a lot of these things that he said, I think, are very true now, more than 15 years later, and I was just going to highlight a few of them and try to show you how they apply to the military. First thing, on an institutional level, most of the things that will most affect institutions will be things that are generated externally and not the result of their knowledge base. Okay? In the past, in the areas of steel and railroads, the knowledge base that these large institutions had was everything they needed to do everything. Now, he's claiming that in the future this would change. And because of this, he said, all institutions must adopt an entrepreneurial attitude. Basically says, organize to abandon any products or services that don't represent an optimal use of your resources. And he said that in his mind, entrepreneurism and good management are really both parts of the same task, and that the entrepreneur that cannot manage will not last long, and the manager, okay, who cannot innovate will also not last very long in the future. From a management standpoint, he said that managers must, number one, organize for the systematic and continuing improvement in the military. Number two, organize for systematic continuing exploitation of what you know to plan for a new tomorrow. Okay? And I'll try to give you, though, I think the military analogs of this are. Third, he said he thinks they're going to have to organize for systematic innovation with the goal of replacing, creating a new tomorrow which will make obsolete, and to a large extent replace these in the most successful current products. So there were 3 steps to what he said managers have to think about. Number one, get better at what you do now. Number 2, use what you know now to do better in the future. And number 3, look for the things, that are so new that you don't have them operationally anywhere right now, but which may just displace things that you know already. A couple of examples. I'll get to that later. Now, this is what I think his conclusions are and how they apply to the DoD. Today's world is changing very rapidly. We have rapidly changing threats. The old thing I grew up with where we would forecast a Soviet threat, 5 or 7 years into the future, has become almost impossible, if not so. The globalization of critical technologies. Again, when I first started in the DoD, we worried about globalization, but it was manufacturing. Then it went to manufacturing and engineering. And now it's everything. R&D, engineering, manufacturing have now become global. And look at all of the big companies. They've moved numerous R&D centers overseas so that they can capture the brain power that's involved over there. Rapidly shifting rules of engagement. I mean, that seems to be something that now is driven by a lot of factors that are beyond the military's control. And they change very rapidly. And finally, of course, the increasing role of affordability, where as you look at the price of an F-35, and some other things, we can price ourselves right out of having any planes left or something like that because of the increasing technology. What this means is DoD, I don't think, or can any longer manage or control change. Change is going to come a lot of times due to external factors. It's got to stay ahead of it with speed, flexibility, and adaptability. For future national defense, I think change will be the rule, not the exception. So I think the idea of these long-range plans in a lot of areas is something that was useful a long time, but is now outdated. Now, just like I think in the business world, there's an analog to the DoD world, I want to talk about what Drucker said were the 4 things that had to be done to deal with this changing world and how I think they apply to the Army. The first one was the organized abandonment of current thinking. The old revolution of military affairs and the things that will follow, the thinking along those lines is really the DoD institutional attempt to try to solve this kind of a problem. The old emphasis was on precision weapons. There'll be variations of this revolution in military affairs that'll come on again, which will be DoD as an institution trying to deal with this changing world. Systematic continuing improvement. For the military, this is training. Training, experimentation, service and joint labs. This is where you're taking your current force, and trying to make them work better than they've ever worked before, with what they have in their hands right now. This is the current Army. The next one is build a different tomorrow based on proven today. That's the requirements-based R&D. That's the work that's going on that has a schedule, okay? We've got programs of record. This is the future Army. The armies that you're going to have in the next 5 or 10 years is coming out of here. Okay. And then finally, the systematic innovation, okay, to make current ways of doing things obsolete. Well, this is essentially the Army after next, because nothing that's this radical, even it works, is going to be available in the near future. Okay, it just doesn't work that way. It takes a long time. And of course, radical innovation is one of the reasons DARPA was created in the DoD, to be a single agency that works for the whole DoD, looking for opportunities, okay, to technically enable innovation. And I'll often be using DARPA, and that's because that's where I worked. Okay? But this is important. Those 3 steps, the military is following, and that has joint programs with DARPA. It's got its own R&D, requirements-based R&D that's going on in its own laboratories and centers. And then it's doing a training of its current force. Now I want to get a little more specific about future Army technology paradigms, examples. First is a statement I'm going to make. Today, the Army depends on technological superiority to enable operational dominance. The Army no longer is a place where mass, okay, is the approach, where you outnumber them 10 to 1, and you go do that, and you just use mass in order to do it. Examples of operational technical superiority include the ability to fight at night. Air-ground coordinated operations. Areas where make the Army, indirect precision fires. There's another Army unique technical superiority that gives it an edge in war fighting as compared to just numbers. The second point about technical superiority is the one that I want to stress, and I'll say later. This is going to be very, very difficult and very different from the past in the future. The main reason for this is, first, technology globalization. It doesn't allow us to use the U.S. and the Army and the Navy and the Air Force, okay, to continue to use the model that worked so well from World War II to almost the end of the 20th century. The Army is going to have to make some tough choices when it comes to technologies. What technologies is it going to own? That means it takes care of that technology from birth to death. It owns it. An example for this, for the Navy, is nuclear propulsion. The nuclear Navy owns propulsion from the development phase, through construction, through deployments, okay, through operations, and then finally when they have to retire it, they take care of that too. It's very costly to do that. You can't do that with every single technology, and in some cases you can't do it at all because the technology is already globalized. These are tough choices the Army leadership is going to have to make, okay, as to what they own. The second one is the choices of where are they going to lead? They won't own it, but they will be ahead of everybody in every single aspect of this technology. And that's not as expensive as owning it, okay, but it is a choice. You can't do it for everything. You just can't. The third choice is where you're going to be an agile adopter. Somebody call that a fast follower? I forget. Right? Okay? And that basically means where you're going to have knowledge of what's going on in these technologies that are important to you. You're going to know who's doing it, and you're going to know how to get your hands on it, okay, and get it to your use as soon as possible. And it won't be the ones where you're doing all of the lead work. I think it's important for the Army to sit down when it comes to innovation and say to themselves, what are the things we depend on from a technology standpoint, and what are we willing to buy into at these different levels? And there's different names for all three of these that people use. But basically, is you own it birth to death, you're the leader, okay? Or third, what you're going to do is you're going to be an agile adopter. The last point I want to make here is, given this change, invention, innovation, and entrepreneurship are all going to be important for the Army to handle this future when it comes to technology. Okay? And that's the thing that will provide them with the flexibility, the speed, and adaptability. The problem with this approach is that given the globalization of technology in this world, this approach also allows other people, newcomers into the conflict game, to go from being newcomers rapidly, if they're good, okay, and have some resources, to becoming contenders very rapidly. We've learned that. Okay, smart people can access things that can do us a great deal of damage, just the same way that we could do it if we don't want to hold it all. So the IIE thing is a good idea, but it's a double-edged sword. Given that, I think it makes an even stronger case for speed, flexibility, and adaptability on the Army's part, as compared to controlling what's going to happen in the future. I want to take a minute to try to give like everybody else has here, give my definition of invention, innovation, and entrepreneurship. First, invention. It's a new device, a new process, okay? It's either a follow-on to something you have now or something you didn't have before. When it first came around, radar didn't exist anyplace. The radar as a technical tool to enable things. And it could be something that comes from a development of a current technology. Okay? That's an invention or a novelty, something new. Innovation comes in next. Innovation is when you use one of these inventions, whether it's an organizational invention, financial invention, or technical, as I alluded to affect the way you operate. That's a big difference from just showing that it works. Now you've got to integrate it with your operations. Very, very difficult problem, okay? And this can be an incremental change in how you operate or a revolutionary change in how you operate. Let me give you an example. The credit card was an invention. It was a little thing that you could use, put information on the back. And then somebody at some point thought about creating something called an ATM, which was a machine that you inserted a credit card into, and then after that a debit card, and it allowed you to do banking 24 hours a day, 7 days a week, and finally internationally. That revolutionized banking. You didn't have to go to the bank between 10 and 3, like when I was young, to get your money out of your account or to deposit money. So that one technical enabler, and the credit card, the writing on the little thing, was a technical enabler, but then somebody thought about how to use that, okay, to revolutionize banking operations, financial operations in this case. So those are examples of how an invention, or one example, is used to revolutionize operations. I want to talk a little bit more now about innovation, and I'm going to make a cartoon here to try to explain. So please take it for what it is. It's a cartoon, but just to try to make a point. Oh, finally, before I forget, the entrepreneur is the person who creates the innovation, who uses, okay, the invention to try to change operations. And the entrepreneur is the person that's been talked about before in the service of people who are difficult to work with. They're often quite creative, but they're the ones who are driven, okay, to take this action. And my experience with the people who do this is they're all driven for their own reasons. Some of them they want to claim, some of them they want to make a change in the world, whatever. These are the people who are the people who make the change take place initially. Now let me talk a minute about innovation. First point, I'm going to repeat something I said before. Innovation is more than invention. It represents a change in operations using some enabler, some invention, some novelty. It could be a lot of different things that are useful, but it's much more than invention. If I could draw a curve of performance of something, whether it be drug manufacturing or profit from a drug company, okay, on the vertical axis, and then on the horizontal axis, draw what I invest to get that performance, whether it's time or resources or both, okay? A typical performance curve for this kind of activity, it looks like this. And this is, again, a cartoon, please. Starts off initially where you don't get much increase in performance. Then if the thing starts to work well in operations, you start to get a rapid increase in performance, okay? And as time goes on, okay, due to competition or something else, your performance starts to level out. And that more investment won't give you much more performance. Okay? This kind of stuff is usually what's called a development plan. Something you plan out, okay, and you work along this curve, and you've got very smart people doing this, but it's something you thought about ahead of time and you put it into your development process. I call that sustaining. Now, at some point, you're not making much for your investment, so you say, I got to do something different. Okay? So you look for another algorithm, another operational model, and then you try to do something to see, what can I do to switch from this one, where my return on investment or resources is slowing down, and my competitors are starting to catch up, okay, to do something, and then you try to move over. And you need something to allow you to move over, so that's usually some kind of an enabler. In my case, I'm talking about technical enablers. Okay? And then when you move over, quite often, when you first move over from your established way of doing business, your performance will not be as good. Why? Because you've probably honed the old way of doing business to the point where you don't have any losses or anything else. You know exactly how that works. Secondly, once you move over to this new model of operations, okay, there's a good chance that it won't catch, it won't work very well, and you'll just fall off the curve, fall off the cliff. Or you may go for a little while, okay, and then it'll stop performing. So making the judgment of how to do this and when to do it is extremely risky. If you're successful, then you're on another performance curve, and you supersede anything you did previously by a large amount. So it's just a way to show the different aspects of innovation, okay, that you have to go through from an established long-term development plan. This jumping to another curve is no longer part of a new development plan. It's a brand new algorithm that you've developed to do this. And that's what DARPA is supposed to do for the DoD. That's what's called radical innovation. That's DARPA's function. And again, I'm peddling DARPA. I'm sorry, not too much, but it was why they were created. Okay? And let me make a point about this because it's something that, let me finish this chart. Okay? DARPA's mission is to maintain U.S. military technical superiority, to prevent technological surprise by sponsoring. Remember, DARPA is a funding agency. It doesn't do any work itself. It funds other people to do work. Okay? As compared to a laboratory that does work themselves. Okay? And DARPA's job is to bridge the gap. One of the most interesting things I found when I was at DARPA was that given the way our military and Congress work and the whole financial situation, it's a lot of risk for a leader in the military to put something in the budget 2 years out, and you have to put it 2 years out if you're going to get it in any finite time, because from something to go from a POM to money that can go on contract takes 1.5 years to 2 years. I mean, once a POM is written and approved, okay, you got 1.5 to 2 years before money can hit the street and be on contract. So the leadership would like to see some example or some demonstration that what's being done might work. So DARPA would say, okay, we'll upfront the cost of taking it through a prototype. So DARPA would. We take it through a prototype demonstration, and either the admirals or the generals would go to the prototype, and the thing worked like gangbusters. I mean, they did all the prototyping, and the thing flew, and this, or whatever. Okay? That's the good news. The bad news is the general would turn around to his aide and say, I want that. Yes, sir. Put it in the next POM. Put it in the next POM, and then 2 years later, RFPs would hit the street. By that time, the teams of people who had been building these things and prototyping them have all disappeared because their contractors put them to work on something else, and you essentially lost another year while you went back from ground zero. That's the valley of death, by the way. That's that hole that exists in the way that we do procurement, which doesn't allow very well for something you can't plan for 2 or 3 years ahead of time. And I don't know what to do about that, but it's something that the only way we knew how to deal with it was if the leaders put some money in the budget now that they might lose if that prototype didn't work. Because then what would happen if the prototype failed? They would go to Congress for a review. Congress would say, that's not working. We'll give me that money back. So it's one of the problems that the military had whenever they tried to grab something that DARPA had demonstrated. Now I'd like to talk about some lessons, and that's one of the lessons learned, by the way, on radical innovation. Let me talk about some lessons. First is, radical innovation requires creative people, that's a zealous champion who's going to dedicate his or her career to this project for their own reasons, a high-level protector who will shield this person, okay, from all of the problems that will happen within a large organization when something really new starts to appear. That doesn't happen very much during war. This is a real problem during peacetime. Okay? In this case, the most important point I make is that organization and management are very people-dependent in this process. The next point is, I don't care what anybody says, for a large organization, innovation, major radical innovation takes a very long time. Okay? It requires experimentally based iterations versus demonstrations. Demonstrations are when you take somebody in and you say, I designed this to work here, and you show it and it works right there. Experimentation is where you say, I designed it to work here and it does, but I'm going to show you now the soft points around the edges of my requirements parameter. Well, how does it fail? And how can I control how it fails? Okay? It takes a lot, and that you usually require iteration. I think Dean made the point about that. It's an iterative process because you learn from the experiments as to what doesn't work. This one here, it almost always displaces or disrupts the well-established current operation. Example, I run a pharmaceutical company. I'm working on a super drug to relieve pain, okay? And I'm funding it. And all of a sudden, the guy in my organization who makes aspirin comes in and says, what, are you crazy? You develop that, and you're going to take away my market for aspirin, okay? Because it'll be cheaper and better, and you're going to cut, your own throat. So all of a sudden, what's happening in your organization is, to a great extent, okay, your own operation is attacking this new innovation. And that's the reason for the protector. Especially for radical innovation, it has to be somebody at a reasonably high level who will protect the zealot. Because otherwise the organization will attack and eliminate it. So I'm going to list up some DARPA-led innovations now. There's 4 of them that are older. Space before NASA, stealth, internet, and Global Hawk. Global Hawk was ending and transitioning out of DARPA to the Air Force when I got there. We had already done the demo at that point. The next 4, with the little stars next to them, are some that I was personally involved with. Arsenal ship was well before I got to DARPA. I was a member of the CNO executive panel, so I got involved in it. And the other ones would fall into the category of systems of networked manned and unmanned platforms, which includes the U-class, which is the unmanned carrier-launched combat air vehicle, FCS, networking of UUVs, future ASW. The last 4 are items that are still in process, pretty much. Okay? The advanced prosthetics, as was mentioned by Dean, I think, was something that DARPA started 10 years ago, more than that, and has now been used to help some of our GIs returning from the wars, and will have incredible impact in the future. Advanced manufacturing techniques may be used eventually for the ground combat vehicle and some of the parts of that, the follow-on to MCS. Okay? Cybersecurity is getting a big push at DARPA because we're realizing now that for defense we need strong, and a lot of that's very, very risky. Finally, hypersonic test vehicle for what's called conventional prompt global strike, which is basically a Mach, in the DARPA version was a Mach 22 flyer, gliding vehicle that could cover the distance between the continental U.S. and any place in the world at hypersonic speeds. It's a glider, basically a boost glider. Goes up, comes down, then glides to the target with precision of 10 yards or something like that. The vehicles DARPA had failed, but it looks like the Navy's picking this up now, and for good reason, because it looks like this may provide the submarine force, okay, with a way to do battlefield preparation against A2AD defenses. Let me talk about those 4 that I talked to you about a minute. Arsenal ship. This was really a concept promoted by the CNO, Mike Borda, back in around '94. As a member of his advisory panel, we suggested he should try to cut a deal, okay, with DARPA to build a prototype. Borda and DARPA went and talked, and they started building a prototype. Then what happened? They got funding. In 1996, I believe it was, Admiral Borda died of suicide. Okay, the champion was gone. He was going to be the protector of this crazy. It was a weapons barge, basically, with 500 missiles and a very small crew that would, give land fire support to multiple services. And it turns out his successor, Admiral Johnson, canceled the program, his funding. Once the Navy canceled that program, DARPA shut the program down because it was supposed to be jointly funded. Now, subsequent, the submarine Navy decided that they could convert some Ohio-class submarines to SSGNs, guided missile submarines, and put 154 of these missiles on every one of them compared to 500. So the idea survived, but not the original program. Why? Because one of the critical components, the protector, went away, and the institution ate it up. The other one is the U-class. There's a picture of it landing in July of 13 on the carrier, Bush. Okay. I was the one who first went to talk to the CNO about this, Admiral Johnson, and he was an aviator, by the way, on this development, and that DARPA would be the initial manager, and then it would be transferred to the Navy. The program was delayed for multiple reasons after I left DARPA, including transfer of some people out of the Navy, and delay of the F-35 deployment. And now the Navy had a problem because it couldn't say, I want the F-35 and the U-class at the same time. They'd lose one of them, so they got to them. To date, the X-47 has now demonstrated carrier takeoff, landing, deck handling operation, and operation with manned F-A-18s and other planes. Unfortunately, future procurement is going to be delayed on the Navy internal disagreement over requirements. Are you going to have an ISR bird? Are you going to have something that'll go after high-risk targets? Congress is going to decide a lot about that. And finally, I think U-class will revolutionize naval air. But it's taken a long time coming. Army DARPA FCS program. The weight of the M1A1, this was back in 98. M1A1 made tactical airlift impossible at that time. You couldn't get it on most planes that could land tactically in a lot of places. C-5A was it, because of the weight of the M1A1. I got called by General Shinseki, and he said, you guys got DARPA can do anything about this? And we put our heads together and said, okay, well, we're going to see if it's possible to use robotics, non-line-of-sight fires, networking, to distribute the functions that at that point were integrated into one big, heavy platform, a battleship, essentially. Okay? And then maintain lethality, survivability, and maneuverability, but allow for tactical airlift to work. Very risky, technically, very. Okay? Started in 99 as a program, I remember. It was General Shinseki, General Abrams, and myself signed the agreements to the program. And what made this one unique, it was parallel development of requirements and technology, as compared to I'll develop the requirements and then you build the technology you need, because General Shinseki said, no, I want to do it faster. FCS. Well, a war comes along a year after the program starts. And it really had strong impact on everything. And really, the need for solutions to critical near-term problems started to take priority. Okay? Also, I think the FCS program had too optimistic a deployment schedule. I left DARPA just as the program was getting underway in 2001, but I stayed involved in some aspects of the program until about 2008. And I tell you, I think the platform focus, instead of the networking and other things, shaped the focus of the program in the early days. Very little experimentation in the early days on communication, command, control, and communications, and this horrible network problem that they were trying to solve, okay? Robotics never got much treatment, a little leader-follower stuff, but not much. And towards the end of the program, there was some good networking that started to get worked on. Unfortunately, at that point, the cost got too high, and the Army program was canceled. We replaced with a new program. A lot of technologies transferred, but the total transformation thing that we tried for the Army as a total system transformation didn't work. The last one I'm going to talk about is UUVs. UUVs have been around for a long time. New submarines are very difficult. The Navy's got a real problem. Okay? 3 technical changes that happened in the last 20 years have made a difference. The first is underwater acoustic networking. Now we've learned how to do it. Very difficult problem because of the environment primarily. So that's been demonstrated. Gliding UUVs with very long endurance so that they don't have to power their way. They use the local currents and thermals to get from A to B. They go slower, but they can stay there for very long times underwater. And then finally, algorithms for autonomous operation as compared to a stick that's guiding it, that have started to work fairly well. I think this may provide a way for the Navy to reliably detect and track and eventually engage in early phases, very early phases of possible conflict, what the Navy calls phase 0. And I think the prototype systems are now in experimental phase, so we'll see what happens there. This is one the Navy, the submarine Navy, has embraced. Okay, so hope these examples have helped to explain some of these factors I talked about generally and how they have impacted attempts to do innovation. Here are the takeaways. Number one, okay, technology globalization will be a major factor in shaping the way that the Army, S&T, is going to do its investments and management in the future. The old way is not going to work. Okay? Global scouting, and I'm going to use the word scouting as compared to intelligence, where you use technically savvy people, Army people, okay, to do what people in industry do all the time. Find out what other companies are doing. We already do this at DARPA with other governments, but we don't do it very well with companies, okay, in other countries. I think this is going to be absolutely critical. These scouts have to be very technically savvy. They got to know what the Army needs are, okay? And they're going to have to travel a lot too, you know, to go all over the world. One of the things that's interesting is universities can play an important role in this case since they already have global networks. Most of the top-notch universities in the U.S. have established global networks, okay, that are manned, a lot of them, by students who went here, got their degrees, and then went back to their own country. So there may be a way that something can be worked with that. Okay, Triple E, more important than the past. And finally, this is I think in the future, technically savvy people are going to have to be brought to the policy table, people who understand the difference between science and good engineering, okay, to have an increasingly important role. I think this is important because we've seen too many people with good scientific backgrounds mislead leaders on how hard it is to build something as compared to understand how it works. And I think one of the best definitions I have found about the difference between science and engineering is on this last chart where a pretty good aerodynamicist, Theodore von Karman, Theodore von Karman said what he said here. The job of the scientist is to discover, okay, the world that exists, and the job of the engineer is to create the world that never was. Thank you. Any questions?